Hey everyone, this is Akanksha and today we'll be solving reverse linked list. This is an easy question, but you know what? This approach or this particular concept is used in multiple difficult questions. So it is good to know how to reverse a linked list. Given a linked list 1, 2, 3, 4, 5 null, you just have to reverse it. So 5, 4, 3, 2, 1 and null. Isn't it easy? So let's see how to solve it. So for the edge case, we'll write if my head is equal to null, that is an empty list, or my head dot next is equal to null. That means we just have one element in our list, so we'll return it because we cannot reverse a list with one element. If not, then we'll initialize multiple nodes here. So let's say our current is equals to head. So whenever you solve a linked list question, always use current pointer because that way you'll actually be able to keep track of the current node of a list, and we'll initialize our previous as null and our next as null. Now we'll say while my current is not equals to null. So this is the use of current. In order to traverse through all the elements of our list, we should do it using a current pointer. So if for my current is not equals to null, we'll say next is equals to current dot next because we have to keep track of our next. Then we'll say our current dot next is equals to previous. For the first case, it will be null, and our previous is equals to current, and our current is equals to next. And after this loop, we'll just return our previous. Okay, so what we are doing is we are just keeping track of the next element because we'll be changing our pointer to the previous one. So my current dot next is equals to next, then my current dot next is equals to previous, my previous is equals to current, and my current is equals to next. So these two lines are just used to move ahead, while these two lines are used in order to change our index from our next to our previous. And at last our current will point to null, so our previous will point to our last element, and then that particular element will be our new head. Let's see if it works. It does. Let's submit and see. Perfect. Now, if I have to speak of time complexity, I'll say we are traversing through all the elements of this list or all the nodes of this list. So our time complexity will be O of n, where n is the number of nodes. And that's it. It's a pretty simple solution. Don't you agree? But it's an important one, again, because this particular concept is used in multiple difficult questions, which we'll see in future. Hope you like the video, and if you do not forget to like and subscribe, and see you in the next video. Bye.